In item number 1 on the second test, we are asked to find the location of the centroid, in particular the height of the location, but to do that with respect to the top of the beam. So that means that we want to set up a reference datum that's up here at the top that all distances will be measured from. This is crucial that we are careful in our work to show that. This is again a reinforced concrete beam, or in particular actually a post-tension beam, but where we have holes for the ducts, and so we are only looking at the concrete centroid. And there's a lot of different ways that one might break up this section, but one simple way is to do it like so, where the rectangles all have a common base, and that base reference point is on our datum itself. That will make our work absolutely easier as a result. So we come in and we identify where the simple locations of these rectangles are. We've got two that are identical here at the top, and then we've got this big one, and then we've got the holes down here. And so let's get these locations identified for the centroids. That first one has a total height of 4 inches, so centroid's down at 2 inches, total height of 20. So that next one is down at 10 inches, and then the final one is 20 minus 17.25, rather 20 minus 2.5 to get to 17.5 degree. And that's down to the center of those. And so those will be the individual Y bars for each one of those pieces. Right? And so to find this centroid location, we're going to do first moments of area. And we want to set up that Y bar for the total times the total area is equal to the sum. It's equivalent to the sum of the individual first moments of area. So that would be then, let's see, we've got two of these small little rectangles, so 2 times then a 6, see that's 24 minus 12, so there's net left of 12, and we could have just done this as one rectangle, but we'll do it as 2 small ones. So 6 times 4 times then their moment arm, that will be cubic inches, right, and there's 2 of those, right, and then plus, let's see, this one is 12 times 20 pi times a moment arm of 10, and then we're going to subtract off the holes. There are 4 of those, and their area will be pi r squared or pi d squared over 4, and then times the moment arm is 17.5. And when we work that out, we'll have 2,441.0 and change cubic inches for that. Right, so that's just the first moment of area, and then the total area, and of course is just going to be the sum of all of our little smaller areas that we've done so far. We actually already have the information in the first moment calculation. We've got 2 of the 6 by 4s plus 1 of the 12 by 20s, and then subtract off 4 of the holes, and that net area then will be 284.8 and change square inches. And now finally we can solve for our requested value of Y bar for the total by dividing these two and then that will equal 2441 divided by 284.8, and I'll get an answer that's 8.57 inches, right? Cubic inches over square inches, leaving us inches, and there's our answer for number 1 from the top. My bar equals 8.57 inches.